For today's lesson, we will be discussing about rational equations. So we will discuss first what is a rational expression, and then we will be discussing also how to solve rational equations. So first, let's recall what is a rational expression. So rational expression, it is a fraction whose numerator and denominator are both polynomials, can be written in the form a over b, where a and b are both polynomials and b is not equal to 0. So take note that rational expressions, the numerator and denominator should be both polynomials. And of course, b is not equal to 0, or the denominator should not be equal to 0. What will happen if the denominator is equal to 0? Then the expression will become undefined. So make sure that the denominator is not equal to 0. Here are some examples of rational expressions. 3 over x minus 2. So both 3 and x minus 2 are polynomials. We also have x minus 2 over x plus 1. And last, we have x squared plus 1 over x minus 6. So again, these are examples of rational expressions since the numerator and the denominator are both polynomials and the denominator, or b, is not equal to 0. How about non-examples of rational expressions? So square root of x over 3 is not considered as a rational expression since the numerator is not a polynomial. Now, why is square root of x not a polynomial? Because it cannot be expressed in an expression wherein the exponent is an integer. So square root of x is not a polynomial. Same as with x raised to 1/2 plus 4 over x. Now, this is again not an example of a rational expression since the numerator, or specifically we have x raised to 1/2. So as you can see, the exponent is not an integer, so it's a fraction. So that means it's not considered as a polynomial. Last is we have x squared plus 2x plus 4 all over square root of x minus 3. So this one is also not considered as a rational expression since the denominator here, which is square root of x minus 3, cannot be written in an expression wherein the exponent is again an integer. So it's not considered as a polynomial. So if one of the numerator or denominator is not a polynomial, then it is not considered now as a rational expression. Now, how will it become now a rational equation? So if we now equate rational expressions into a certain number or another rational expression, then we will have rational equation. So rational equation is an equation that contains at least one rational expression. So again, with rational equation, there should be at least one rational expression. Example, we have 3x over x plus 1 equals 4. So this is an example of a rational equation since we have this first here, we have 3x over x plus 1. This is a rational expression and it is equated to a certain number. So in this one, a rational expression is present. An example also can be x minus 2 over x plus 1 equals -1. And last is we have x squared minus 3 over x minus 6 equals 2. So these are examples of rational equations. Now in rational equations, we also have what we call as solutions or roots. Now these are the values that satisfy a given rational equation. So given that you have a rational equation, if you identify the roots or the solution, this must satisfy the given rational equation. Now example, the value x equals 3 is a solution to the rational equation 6 over x minus 1 equals 3. Now why is x equals 3 a solution to the given rational equation? Because once you substitute the value of x, which is 3, to the given equation, it should be equal, or it should be true. So we can have, let's try, 6 over, then we have 3 minus 1 equal to 3. this will become 6 over 2 equals 3. So we now have 3 equals 3. So that means the value x equals 3 is now a solution, or we call it as the roots of the given rational equation. We also have what we call as extraneous solutions. So these are the values that emerge from the process of solving the equation but do not satisfy a given rational equation because it makes some quantities in the equation undefined. So once you substitute the solutions that you obtain and it happens that it makes some quantities undefined, then you will call it now as extraneous solutions. Example. So in solving 5x minus 10 over x squared minus 4, x will be equal to 2 and 3. So as you can see here, there are two values of x, or we have two solutions as we solve the given rational expression. Now, if you substitute this to the given rational expression, let's say we have 2, 5 times 2 minus 10 equals, we have 2 squared minus 4. If you simplify this will become 10 minus 10 over 2 squared minus 4. So this is just 4 minus 4. So we have 0 over 0. And then if we will solve for 3, 5 times 3 minus 10 all over 3 squared minus 4. This time we have 15 minus 10 over 9 minus 4. Or we have 5 over 5, which is equal to 1. Now, as you can see here, after we substitute, you will notice that for 2, the value will be 0 over 0. Now, this means that the given expression now is indeterminate, since both the numerator and the denominator is equal to 0. So it will become an error. And if we substitute 3 to the expression, the value is equal to 1. So there's no problem at all. That means 2 is an extraneous solution, because after we substitute, the expression now becomes indeterminate, or sometimes it will be undefined. So we cannot consider 2 as a solution. We will only consider 3. Again, 2 here is what we call as the extraneous solution. Now let's try to solve some rational equations. So in solving rational equations, there are two ways on how to do it. First, you can identify the LCD. Second is we can do cross multiplication. So let me show you first how to do it with using LCD. So we know we have x over x plus 1 equals 4/3. Now, since there are fractions, that means we have to get the LCD, or the least common denominators. So in doing that, you have to identify the factors of the denominator. So for the first one, we have x plus 1. And for the second is we have 3. Now, since these two denominators are already factored, then that means we will use them. Now, how will you identify the LCD? This is the product of the prime factors of each denominator. So since there's only one factor, obviously, so the LCD will be x plus 1 times 3. Then what you will do is you just have to multiply the whole equation with the LCD. So we will now multiply both sides by x plus 1 times 3. So we have times x over x plus 1 equals 4/3. Then again, you multiply the other side by x plus 1 times 3. Okay, so we can do it like that. So what you will do is we can cancel out x plus 1, so you will just left with 3. So 3x. So we have 3x here, 3 times x equals. Then on the other side, we can cancel out 3. And then you will left with 4 times x plus 1. And then all you have to do now is to simplify. So 3x equals 4 times x plus 4. So all you have to do is to distribute. And then you isolate all the terms with variable x on the other side. So we have 3x minus 4x equals 4. Negative x equals 4. Or this gives us now x equals negative 4. So this is now the value of x, or this is now the solution. Now to check, all you have to do is to substitute. So checking. We always have to check because there might be extraneous solutions. So even though there's only one, so let's just do it. Let's just check. So all you have to do is to substitute, and both sides must be equal. So negative 4 over negative 4 plus 1 equals 4 over 3. So the numerator will be negative 4 over negative 4 plus 1 is negative 3 equals 4 over 3. Now, since both of the numerator and denominator are negative, so you can simplify them. Negative divided by negative is positive, so we will just have 4/3, which is again equal to 4/3. So it's correct. So that means x equals negative 4, or negative 4 is our solution. Now, what if we want to use the cross multiplication? So all you have to do is, so just write x over x plus 1 equals 4/3. In cross multiplication, all you have to do is to multiply the denominator to the numerator of the other expression and simplify. So in this case, we will multiply 3 to x, and we will multiply x plus 1 to 4. So that's why it's called cross multiplication. So again, you multiply 3 to x, and we multiply x plus 1 to 4. Then after that, you just have to simplify. So 3 times x is 3x. Then we have 4 times x plus 1, so we have 4x plus 4. So again, distribute. So all you have to do now is to simplify. So we have 3x minus 4x equals 4. Negative x equals 4, or x is equal to negative 4. So as you can see, we also got the same answer, which is x equals negative 4. So it's either you use the LCD or you do cross multiplication. Next is find the solution or solutions of 4 over y plus 4 equals y over 3. So looking at the given rational equation, we can do, or it will be easier if we will do cross multiplication. So we have 4 over y plus 4 equals y over 3. So do cross multiplication. So you multiply 4 to 3, you multiply y plus 4 to y. So 4 times 3 equals, we have y times y plus 4. Then simplify this. 4 times 3 is 12 equals, then we have y times y is y squared. Y times 4 is positive 4y. Now as you can see, although the terms with y variable are already isolated on the other side, we cannot do anything to it. We cannot combine y squared and 4y. So what we will do is, let's put all the terms on the other side of the equation, and then we equate it to 0. So we can transfer 12 on the other side. So this will be 0 equals y squared plus 4y minus 12. If we will flip this, we'll have y squared plus 4y minus 12 equal to 0. Now as you can see, we now have a quadratic equation. So in order for us to solve for the values of y, what we need to do is to do factoring. So let me just write it here. Y squared plus 4y minus 12 equal to 0. Now how are you going to do factoring? So you find factors of the first term, find factors of the third term. So let's write here y. Since the first term is just y squared, so the only factors are y times y. For the last term, since it's negative 12, you have to identify factors wherein if you multiply, of course you will get negative 12, but if you add, you will get positive 4. So what can be the possible factors? So we can have positive 6 times negative 2. So positive 6 times negative 2, that will give you negative 12. And if you add positive 6 and negative 2, so 6 plus negative 2, that will give you positive 4. So that means our factors are correct. Or you can also do this. You multiply 6 to y, you have 6y. Multiply 6 and negative 2, you have negative 2y. And then you add, so you will get 4y, which is our middle term. So that means the factors are correct. Now, all you have to do is to equate each factor to 0. So you have y plus 6 equals 0 and y minus 2 equals 0. And then you will have y equals negative 6. So that is the first value of y. And then we have y equals 2. So we now have two values of y. So for checking, we have to check the two values of y. So checking. Let's try y. So for y equals negative 6. So all you have to do is to substitute 4 over negative 6 plus 4. It should be equal to negative 6 over 3. So this will become 4 over negative 6 plus 4 is negative 2. So negative 6 over 3 is just negative 2. 4 divided by negative 2 is negative 2. And it's equal to negative 2 of the other side. So that means we can say that negative 6 is a solution. For the next one, we have y equals 2. So y equals 2. We have 4 over 2 plus 4 equals 2 over 3. And then we have 4 over 2 plus 3 is 6. Then 2 over 3. So if we simplify 4 over 6, we will get 2/3 as well. So that means 2 is also a solution. So we have two solutions or roots for the given equation. We have y equals negative 6 and y equals 2. Another example. 2 over x plus 7 equals 3 over x plus 4. So let's just again do cross multiplication. Then we have 3 over x plus 4. So you multiply x plus 4 to 2 and you multiply x plus 7 to 3. Again, we're doing cross multiplication. Then let's distribute. We have 2x plus 8 equals, then we have 3x plus 21. Now let's isolate all the terms with variables on the other side. So we have 2x minus 3x equals, then we have 21, then 8, you move it on the other side, minus 8. So 2x minus 3x is negative x equals 21 minus 8 is 13. So we have 13. And then since this is negative, just multiply by negative 1. So we have x equals negative 13. So this is now the value of x, or this is now the solution. Now let's check. So for checking, substitute, we just have to substitute. So 2 over negative 13 plus 7 equals 3 over negative 13 plus 4. So we have 2 over, then negative 13 plus 7 is 6, or negative 6 equals, then we have negative 13 plus 4 is equal to negative 9. So 3 over negative 9. We can simplify this. 2 over negative 6 is just equal to negative 1/3. And 3 over negative 9 can also be simplified as negative 1/3. So it's correct. So that means negative 13 is the solution of this given rational equation. And for our last example, let's try 8 over x squared plus 2x minus 8 equals x over x plus 4. You can still use the cross multiplication here, or you can use the LCD. So let's try to use LCD here. So in getting the LCD, of course, you have to consider the denominator of each rational expressions. So we have x squared plus 2x minus 8, which can still be factored as x plus 4 and x minus 2. So 4 times negative 2 is negative 8. If you add positive 4 and negative 2, you will get positive 2. So that is the factored form of the denominator of the first rational expression. For the second one, we have x plus 4. So it's already in simplified form, so we can't do anything about it. Now notice that for each denominator, they have common factors, which is x plus 4. Now for the LCD, we have to identify the prime factors that exist in each denominator. So in the first one, of course, we have x plus 4. Now we will just write it once because it also appears with the other denominator. So no need to write them both. So we just have x plus 4 and then the other one is x minus 2. Because again, that is another prime factor. Now that you already have the LCD, all we have to do is to multiply the whole expression by it. So we have x plus 4 times x minus 2. Then we will multiply it over. Now instead of writing the whole expression, or instead of writing the original expression, we can just write the factored form so that we can easily cancel. So x plus 4 times x minus 2 equals x over x plus 4, and then you multiply it with the LCD, x plus 4 x minus 2. So again, cancel out. So x plus 4 is cancelled, as well as x minus 2. So we're just left with 8. On the other side, we can cancel out x plus 4 and we will just be left with x minus 2. And you have to multiply it to x. X times x minus 2. So simplify this, we have 8 equals, distribute, so x squared minus 2x. Now we cannot combine x squared and negative 2x, so what we will do is we move 8 on the other side and then equate to 0. So 0 equals x squared minus 2x minus 8. Now that we already have a quadratic equation, what we will do is to factor so that we can solve for the values of x. So we have x here. Now factors of negative 8, so we have 4 and 2, but this time 4 is negative and 2 is positive. So negative 4 times positive 2 is negative 8. Negative 4 plus 2, we will get negative 2. And then, since we already have the factors, all we have to do now is to equate each factor to 0 to identify the exact value of x. X minus 4 equals 0. X plus 2 equals 0. So we have here x equals 4. And we have x equals negative 2. And then all you have to do now is to check if it will be satisfied or not. So let's check. First, let's have x equals positive 4. So you have to just substitute. So all you have to do is to substitute. So you have 8 over then 4 squared plus 2 times 4 minus 8 equals 4 over 4 plus 4. So this is 8 over 16 plus 8 minus 8 equals 4 over 8. 16 plus 8 minus 8 is just equal to 16. So we have 8 over 16 equal to 4 over 8. Or if we simplify this, we have 1/2 equals 1/2. So the expression or the equation is true in both sides for x equals 4. Now let's try x equals negative 2. So again, let's substitute 8 over negative 2 then squared plus 2 times negative 2 minus 8 equals negative 2 over negative 2 plus 4. So we have 8 over 4 minus 4 minus 8 equals negative 2, and then negative 2 plus 4 is 2. So we have 8 over 4 minus 4 is 0 minus 8, so negative 8 equals negative 2 over 2. If we simplify both sides, we will get negative 1. So it's true. Since after substituting the values of x to the given rational equation, both of them are satisfied or true, that means x equals 4 and x equals negative 2 are considered as solutions of the given rational equation. So that's it for today. I hope you learned something about rational expressions, rational equations, and how we solve them. And see you next time.